Okay guys, the sub should have handed out to you at this point a blue learning packet for Unit 4. Ooh, let me get my color in blue here. Blue, 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 there it is. Okay. What I'm going to do first is give you some basic notes, and then I'm going to tell you what I want you to do. Okay. Now, I already showed you how to do basic Lewis structures. You're going to align everything around the central atom. You're going to attack the lone pairs on the central atom. And if you hit a dead end, you are going to, what are you going to do? Shift. Yes, that's right. You're going to shift. And if you can't shift those electrons to free up a lone pair, you are going to split. Yes, good job. You're going to split. So there are two unique situations I have not talked about. I'm going to do an example of each. The first unique situation is if you have a cation, and your standard example is the ammonium ion. Okay, so you start off doing it normally like you always do. So you're going to put everybody around the central atom. Okay. And you put the valence on the electrons on the outside and the valence on the electrons on the inside. Okay. And before you begin, you have to take this into account. Now this is a positive charge, so this means that ammonium has one less electron. So we have to remove a dot. Now let's think strategically about this. Are we going to remove a dot from hydrogen, or are we going to remove a dot from nitrogen? Now we're not going to take one away from hydrogen, because then we'd lose all the hydrogens. Poor little hydrogen. So we're going to take a dot away from nitrogen, and we're going to take this dot away. So that now we have 4 lonely dots on the nitrogen to match up with the 4 lonely dots on the hydrogen. And we're going to redraw it nicely, like so. Okay? And because this is a polyatomic ion, whenever you have a charge, you put your Lewis structure in brackets and you put the charge at the top. Okay? Now the next situation is if we have an anion. And the carbonate anion is a good example of that. So we're going to put our carbon in the middle because it has the most bonding power. We're going to give carbon its 4 dots and give oxygen its 4 dots. Or, I'm sorry, 6 dots. Welcome to Jamaica. Have a nice day. All right. So we now are going to attack from the outside in. So going to attack that dot. Going to attack that dot. Okay. And I'm going to start over here. Okay. We forgot to take this into account. Okay. So if we look at this charge, whereas with the ammonium ion, we had 1 less electron because there was a positive charge. With the carbonate ion, we're going to have 2 more electrons because there's a negative charge. So let's add those electrons first. My bad on that. So we can really choose where we want to add them. We can add them to the carbon here, but that wouldn't be good because we'd be removing the bonding power on carbon. Poor carbon. And we don't want to add both of them to an oxygen because we lose the oxygen. So what we're going to do is add one of them to one of the oxygens and one of them to another oxygen. Okay? And look what happened. These are going to bond. This is going to go over here and grab that oxygen, and this is going to go over here and grab that oxygen, yielding a Lewis structure that looks like this. And we have to put it in brackets and we have to put a 2 minus at the top to indicate it. So to review, if there's a positive ion charge, you're going to have one less electron, or the number less electrons as the actual oxidation number. So in this case, it's +1, means we have one less electron. We strategically look at a good place to take that electron from. We didn't take it from the hydrogen because we lose the hydrogen. And we didn't take it from one of the lone pairs on the oxygen because we want to use that to bond. We opened up one of the current pairs, yielding this Lewis structure. We put it in brackets and we put the oxidation number on the top right. For negative ions, you add the number of electrons as the number of the oxidation number. So the oxidation number is 2 minus, so we need 2 more electrons. Okay, we look strategically at where we want to add them. We don't really want to add to the center atom because we lose bonding power on the center atom. For instance, if you added them to the middle of oxygen, you lose each of those, or carbon, you lose each of those. So that's not good. So we are going to add 1 to each of the oxygens and then attack accordingly. And here is the Lewis structure. Okay. This here has 4 sigma and no pi, and this has 3 sigma and 1 pi. Okay. So what I'd like you to do now is go through your learning packet, and for each of the Lewis structures indicated, take the formula and draw the Lewis structure in this box. And then what I'd like you to do is just answer the question for the number of sigma and the number of pi bonds. Don't do any of this other stuff. Okay, we're going to get to that when I get back. What I want you to do is just focus on drawing the Lewis structure in the box and answering the sigma and pi bonds.